So it's COMP2084, lesson 1, part 2. So we're going to dive into Visual Studio and kind of see what it can do for us. If you want to fire up your Visual Studio, we're only doing a little tiny bit of coding today. So if you're still installing things, don't panic. You're not going to be missing a ton of stuff that you can't catch up on. We're basically just creating an application and playing around to see how it all fits together. So you'll get this window. You can turn off this startup page. I kind of like it because it still gives us the developer news. So that's similar stuff to what you get on the ASP.NET site. They update this. You can see almost daily with things that are going on. So I'm going to make a new project. So click on File and New Project. The default location it will save them is My Documents, Visual Studio 2017 project. Save the file wherever you like on your machine. It doesn't matter. I've got a folder set up for our course, so I'm going to put it in there. So you can just call yours MVC Music Store. Don't put any spaces in the name. You can call it whatever you want. You want to call it COMP2084. It really doesn't matter. Just make sure there's no spaces in the project name. Okay, right. Sorry. Thank you, Vlad. I should mention. If you don't see this, so make sure you're under Visual C#. Last semester, I actually had a student in this class in winter submit a project that they'd created in Visual Basic. And I didn't mark it even though we're learning C#. He wasn't so happy with his grade. So then under Visual C#, pick Web, and we get these two options. So the first option is .NET Core. We want the second one. We want the .NET Framework version. So pick that. It should default to the latest version of the framework you have installed. If you have a slightly lower version, no problem. Not going to break anything. We'll check off create a directory for a solution, so it'll create a new folder with the same name as your project. For now, we'll leave Git off. We will be using Git regularly, religiously in this class, but I like to do that manually through the command line rather than letting Visual Studio do it. I find Visual Studio's Git is not always reliable. The command line is infinitely more reliable, so I prefer it. So I'll uncheck this. So just click OK here. And that'll bring us up to our second dialog box. So yours probably defaults to empty. You want to make sure we pick the MVC template. So you can obviously see if we want to go old school, we can pick web forms. If we want to build a web API, which we're going to do later, we can pick that. We want MVC, which then checks this box here. That adds in, someone mentioned earlier about support libraries. It adds in all the libraries we need to run MVC apps. We'll get there. One sec. Make sure you check off add unit tests. We're not going to be dealing with unit testing until sometime in November, but it's much easier to add all the unit testing infrastructure and libraries now and let Visual Studio do it automatically. If you create the project without unit testing, it's a lot of work to configure it later for unit testing. Whereas for right now, configuring it is as simple as checking that option. Okay. Please don't check this one, Docker composing. Docker containers for cloud hosting is way beyond the scope of this course. It'll add a huge amount of stuff to the project we don't need, so don't enable Docker. Okay. Docker's kind of a cool thing. It allows your application to run in a container. Then you can simply move that container from server to server and it'll still run. And it's got like all the server settings and infrastructure kind of wrapped in that Docker container. So if you're really bored this semester and there's something you want to learn on your own, go on lynda.com and take a course on Docker. Cool thing to know. Now, thank you, Virginia. Yes, authentication. By default, everything would be public in the application. It defaults to no authentication. We're going to do, right after reading week, we're going to want to add authentication, registration, login, roles and permissions, all that stuff. So again, let's add the infrastructure to that now, because it's a lot of work to add it all manually later. So click the change button and change from none to individual. Individual user accounts lets us create accounts in a SQL Server or other database, as well as it has hooks for OAuth providers like Facebook, Twitter, Google, and Microsoft. These will automatically get added in. We're going to do that, I think, in week 8. We're actually, it should only take us like an hour or two to enable. We're going to add all those things into our music store. So you can sign up by creating an account, or you can just log in with one of those social providers. We also have the ability, if we wanted it to be like on our work or school network, we could pick that account. Or if we were on an intranet and everyone had Windows credentials, we could pick that. So as long as you had an authenticated Windows account, you could authenticate that way. Most public websites, we're going to want this option, right? Individual user accounts, because we don't know who the users are necessarily. So click OK. So there's our template. So when you create assignment 1, when you create your separate project for assignment 1, you're going to pick the exact same options. For assignment 1, you don't really need authentication and you don't need unit tests, but that's parts 2A and 2B. So assignment 2B is basically taking assignment 1 and getting the authentication piece working. And assignment 2B is adding unit tests. So we want to make sure we add all that infrastructure right from the beginning so we don't have to try and tack it on later. That's a pain. Okay. So there's our template, MVC, unit tests, individual user accounts. Okay. I am recording this as well. So if you can't catch up or you have a problem, you can always go back and watch this later. So we'll click OK. And we're going to start to see all of the libraries getting added in as it creates the project for us. So our project, when we're done, is going to be about 130 megabytes. And I think the support libraries will be 112 of that 130 megs. We don't need all the support libraries. I'll probably keep them in my project for now. You can see it's adding in a bunch of jQuery stuff. It's adding in stuff for unit testing. You can kind of see in my status bar what sorts of things. There we go, project's done. So quick links if we want to publish to Azure, or later on we're going to set up continuous delivery. So the way our deployment model is going to work is we're going to connect our application to GitHub. At the end of every class, I'm going to commit to GitHub, and Azure allows us to set up continuous deployment. And rather than using FTP to put our site on Azure, all we have to do is commit to GitHub, connect our Azure site to our GitHub repository. We push changes to GitHub. Every 60 seconds, Azure actually checks that repository for a new commit, and it deploys new changes, which is awesome. We can back up and archive our code and deploy a new version all in one step. Okay, so we'll set that up in the next week or two, probably not today. So here's what we've got. So it scaffolds out, we've got a solution with 2 projects. So this music store that's in bold, that's the actual web application, right? That's got our views, our models, our controllers, all that stuff. And it's bold because that's our primary, considered the primary project. If I contract this one, we also have a secondary project. This is our unit testing project. So we're not going to touch this until week 10 or week 11. And then we'll start writing unit tests in here then. But we want to have it here. So I can kind of close up the unit test project. Don't really need it. We're not going to need that until November. Just good that it's there. So let's look at what's in here. Okay. Under references, this shows you all of the libraries. This is that 112 megs worth of stuff. So it actually has some libraries here for doing artificial intelligence, a bit beyond the scope of what we're doing. It's got some packages related to security. So you see these ASP.NET identity. So that has to do with user authentication and authorization. As well as Owen is this authentication middleware that we're going to use later in the term. And you can see we've got libraries for Facebook, Google, Twitter, and Microsoft. So all we really need to do is create a set of API keys in one of those portals, add the keys to our application, and our OAuth is going to work. We don't have to do anything. The code's actually here. Let's say we want something else. So we talked about what a robust library. Let's say we want to allow GitHub login. We want to allow LinkedIn login, both of which Microsoft now owns, by the way. Right? We don't have it, but Visual Studio has this package manager. So I won't do it. I'll just show you. So if I go to Tools and NuGet Package Manager, There's two versions. One is a command line like you'll do with Node Package Manager, where you can install things. There's also a GUI version. So if I click on Browse, I can search for, let's say, LinkedIn package. There we go. Authorize, I click the package, I click the install button. It adds the library, the code library, and then we just add our LinkedIn API credentials. Boom, we can log in with a LinkedIn account. Wow, pretty simple. So we'll use the package manager. There will be some extra things we're working on, but not today. So those are our references. One of the other things we'll eventually use, and we put this up on GitHub, if 80% of our code is packages, we have a pretty substantial git ignore file. When we push to GitHub, there's no need for us to push all of those packages up and down to GitHub. So our git ignore file is going to ignore those references. So if we download code off of GitHub, if we download an ASP.NET project, typically we're going to have to run a package restore before we can run the app, because all the libraries will be missing when we download it. We've got some startup code here. We'll get into this in a few weeks. So that's for like configuring URLs. If we want to force our site to run under HTTPS, we'll play around with a few of those later. We won't do a lot in there. Just kind of some boilerplate startup code for Microsoft. Content is for static assets. So our CSS goes here. Later on, we'll want some images, so we'll create a content images subfolder, putting things like a little logo in the header, album cover art, and things like that. We'll stick in a content and images folder. Pretty self-explanatory. Inside of controllers, we get 3 by default. The home controller we get automatically from that template. The account and manage controllers, these got added because we changed from no authentication to individual user accounts. Had we left it at no authentication, we'd only have the home controller here. So all of our controllers, all of our logic files, they're going to go inside that controllers folder. If we install our own fonts, there's a folder set up. For models, right now we have 3 models. Again, all of these are around user accounts and identity. So again, this would be blank had we picked no authentication. So later on, we'll build some models and controllers of our own over the next few weeks so that we learn how we work. And then we'll probably blow those away and we'll let Visual Studio auto-generate those for us, which is awesome. So there's kind of 2 models we have, 2 different styles we have for building models in Visual Studio. They have a code-first model. That is, we create all of our class objects ourselves. So if we're building a music store, we'll have like a product class, a customer class, an order class. And we create those much the way you'd write those as a Java class, right? You define all the properties with getters and setters. So in the code-first model, you create all your business objects. Then we connect it to an empty database and we say, hey, Visual Studio, go and build the database for us. And it will take our models and it will generate tables that are mapped to all of those models. So we don't have to build the database and build the models. Or we can do the reverse. They have a database first model, which I tend to prefer, where we take an existing database that has all our tables and relationships. We do a click-through wizard to connect our project to the database, and Visual Studio will build a model for each table in the database with all of the correct property names, getters, setters, data types, and validation rules. So if a field in the database is marked as required, our model will mark that property as a required and it'll write a validation rule. Or we say a string for a first name can only take 50 characters. The model will automatically put in a validation rule saying that it will show an error message if a user puts in a first name that's 51 characters. Okay? So again, they're saving us time. So we can do either way. I prefer the database first model. Build my database first, then build the application on top. Can do it the other way. It's kind of developer preference. Front-end JavaScript. So it automatically pulls in jQuery and Bootstrap for us. If we want to write our own client-side JavaScript or find additional libraries, we can just add them here, link them in. views is where our UI goes. Now our views have got to be organized. Right? So every controller has a corresponding subfolder in views, right? We had home, about, and manage controllers. Well, we have views, home, about, and manage subfolders, and then the individual views go inside. So inside of home, we've got 3 views, about, home, and contact. We have one extra subfolder in views called shared, which is what you would imagine it to be. So inside of shared, we've got an error view. We also have this is kind of a special file. This is basically a site template. So Microsoft gives us a template out of the box. We can blow that away or we can make as many changes as we want. We can have multiple templates. Maybe we have different areas of the site and each area has a different layout. Like we may have an admin area, we may have a supplier area, we may have a customer area, we may have a public area. So we might have different templates that contain the layout for each of those. So every view can use one template file. So that way we don't have to reapply, the layout to each file. Every time we create a new view, we can simply link it up to an existing layout file, which saves us time. The other important file in here is this web.config. This is an application configuration file. So it'll contain database connection string. It'll contain other global settings like is debugging on or off? Do we have a global error page? And if so, what is it? What's the URL? It'll let us contain application-wide variables. Like if our application needs to be able to send mail, well, there's a .NET library to send email. Well, we're going to need to put in the server address and a username and password to authenticate that email account. If we have global paths, right? We want it whenever a user uploads certain kind of file, we want it to go into a certain folder. We can specify all that kind of stuff in web.config. So in a .NET Core app, it has a similar file, but that file, rather than XML format, it's JSON. But it would be similar. So there's our app. Visual Studio also comes with a built-in web server. So Microsoft's web server is called IIS. If you're hosting an application on a Windows server, you're using a shared IIS server. So we actually have our own server. So there's 2 ways to get it started. One way we're going to use 99% of the time, and one way we're going to use 1% of the time. Now, probably you're used to from your C# course when you want to run your application, right, in a desktop environment, you click this play button. That's the 1%. Don't do that. The reason we don't want to click the play button, it launches the server and starts off our app in the browser. The problem is the debug mode is on. And when debug mode is on, you can't make changes to the code. In order to change the code, you have to stop the server, wait for it to stop, make your changes, and start it again. That's what you have to do with desktop development, and it's a pain. With web, they've actually given us a better option. So the 1% of the time, we will use the debugger. When we have an error and we can't figure it out, we need to put a breakpoint in our code and walk through it. Then we'll use the debugging, the active debugger. The rest of the time, we're better off with this option. Under the debug menu, we want to start without debugging. That's still going to start the server. It's still going to launch the app in our browser, but the debugger is not active, so we can just go ahead and change the code without having to press stop and then restart. You can also pick the browser you want. So I've changed mine. By default, Visual Studio is going to load Edge or Internet Explorer. You want your app to run in a different browser, just pick a different browser. Under here, I think you've got the option. So I'm going to choose debug, start without debugging, and it's going to do 3 things. The first thing it's going to do is it's going to compile all of the C# code into a DLL. Second thing it's going to do is start the local web server. And third thing, it's going to open the home page in my default browser. So click debug, start without debugging. So notice it will randomly assign a port to every application. You can change this if you want to hard code the port number, you can. I typically just let it be assigned randomly. So here's what we get for our few clicks and our 130 megabytes worth of stuff. What did we actually get? Well, you get a working site. Cool. Yeah, I see smiles. Exactly. right? Be a lot of work to build all this stuff. So we get a home page, and we have two other pages, right? So notice the URL. So home/about and home/contact. So that suggests that these requests are being handled by the home controller and that there's an about and a contact method in there. We'll check that in a minute. So it gives us a very bootstrappy looking site, as we can see. Because we picked authentication, we also get this. They built us a register form, which we can customize. Built us a login form. If we had enabled Facebook or Google, it'll automatically enable login with Google, Facebook, Microsoft, or Twitter right here. It's mobile responsive with our little hamburger menu. So they've taken a ton of the day-to-day grunt work of setting up an application out. That's what we got for 130 megs worth of disk space, right? Which is not a bad place to start. So we can get rid of anything we want, we can change anything we want, but it's saved us a lot of time to get started. So let's look at how this works. So in controllers, let's open up our home controller. We'll make a few changes here. So in our home, so our controller class, it's just a class file. It inherits from the base controller class. So we've got these references. Visual Studio added these references. These four aren't actually being used right now, so that's why they're gray. The only reference it's actively using is the system.web.mvc namespace in the framework. So we've got three public methods here: index, about, and contact. So we can see when we click on about, that's how it knows to go to the home controller and call the about method. So what happens on our about method? Well, we'll deal with line 18 in a minute. It returns a view. There's a question for you. How does it know what view to return? We haven't told it. Okay, but it's true. But if we look at our views, inside of views and home, what? Right. Notice our view names match the controller names exactly. You can override this, but this is the default behavior. If our controller has methods called index, about, and contact, we want views inside of views and home with the exact same names. So it automatically looks for a view with that name. If I rename the view, maybe I'll change the view to about us. That's what happens. So it's looking for all those different file extensions, ASPX, ASCX, those are web forms extensions. So it's saying, okay, maybe this is old, maybe there's an old web form with this name, and it looks first in home, then it looks in shared for any file called about. So naming your methods and your views together, it's important. Now, you don't have to have the same names. There is a way around this. You can override this. So we have two ways of fixing the error. One is rename the view back to about. We know that works. The other way we can do it is we can specify here, return view as an overloaded method. So if we tell it specifically, load the view called about us, now it should work. Well, I'll refresh. But it didn't work. Give you a hint. I didn't do anything wrong. My code change is correct. I did save. One of the other things Visual Studio will show you, it'll put a little asterisk in the file name here in the tab anytime there's a change. So if you make a change, we know that's unsaved. See the little star as soon as I save. So my change is saved. So why isn't it working? You got it. So what do I have to do? I've got to recompile the code, right? So if we make changes in our views, those get reflected automatically because that's just user interface and HTML. But if we make changes in the server-side code in the C#, in our models or controllers, we've got to recompile. So remember, all of our C# code is in a DLL. Where do we find the DLL? In here. Go into my code, buried down deep in here, inside of the bin folder. So if we look here, we have a DLL with the same name as our project, but notice the timestamp. It's 236. That timestamp was from when I first created and launched the server which built the project. So I've updated the controller, but I haven't recompiled the code. So Lewis is right. It's still running the old version of the DLL timestamp 230. So all I have to do is click on build. And then I either build the solution or I could just build my web project. Because the two projects are linked, they kind of do the same thing. So now I build the solution. It rebuilds my web project DLL. It also recompiles my unit testing project, which we're really not using. If I go back to my Windows directory now, notice it's timestamp 237. So now if I refresh, it should load the view. That code change should take effect. Also notice when every time you build, when you first refresh, it's slow after a compilation. The first request is slow. After that, it's fast. But the page isn't going to load right away. Notice there's a bit of a lag. And as your application gets bigger, those lags tend to be a little longer. Right? So now it works, and it's loading the view that's called about us because I'm specifying that exact name. So other requests are instant, right? It's fast now. It's just that first request after a build operation, it'll be slow. So typically, our method names in the controllers, almost all the time, I don't recommend doing this. Creating a method with one name, calling a view with a different name, and then having to specify. There may be times when you need to do it, but generally we're going to want to match the method names and the view names by convention. It's just simpler. It's less code too. Right? Don't write any code. You don't have to. The other thing I actually want to just mention here is notice the return type of these methods. It's returning an action result. So this is a return type that's specific to the .NET framework. Probably, I'd be very surprised if any of you have ever seen it before. You probably didn't use it in your desktop when you did desktop development. So action result, it's a class, it's part of the system.web.mvc library. Most of the time, 90% of the time, our action results are going to return a view. That's what most of our methods are going to send back, is a view to the browser. The user wants to see something. We could have other types of action results. A few other ones we might see. We might just want to send back some kind of HTTP status code, like an HTTP not found for in other words, a 404 error. Later on, when we build web APIs, we're not returning views. We're just returning probably a JSON object. So JSON or XML are also types of action results we can return. We can also return a redirect result. So rather than loading one view, we then want to call a different method. Right? So we might typically do this, let's say after we add or delete a record. We want to then process that. So we may have a method called add or a method called delete. After it talks to the database and adds our new record, we want to redirect maybe back to the index view. So the user, because the index views in .NET MVC, they usually show a list of all the data in a particular table. So after we add or delete, we'll work in the database and then we'll want to take the user back so they can see the updated list. So we'll use a redirect instead of returning a view. We'll redirect. Most of the time, though, we'll return a view. Yeah. I got 10 minutes. That's fine. That's enough time. Let's talk about this for a minute. Notice we have this view bag. View bag is just nothing more than a quick and dirty container, an easy way to send basically messages or data from the controller to the view. Most of the time, we won't use this. Most of the time, we want to send back an actual object. A list of strongly typed customers, a product object, something like that. If we just want to display simply maybe a message, we can use the view bag. So notice I put a space in here. If we actually open up the view, here's how it renders. So our views are way cleaner than PHP files, right? Because there's no server-side logic on there. It's just what gets rendered to the page for the most part. So again, we have a combination of HTML and our server-side, any server-side contents just prefixed with the @ symbol. Easier to type than a PHP tag and no closing tags to forget and worry about, which is great. If we have a block of server-side code, we just do the @ and a curly brace, open and close. So whatever we put in the view bag in the controller, let's change this. We're sticking that in the view bag and passing it to the view. I'll come and refresh. Why did my page change? Yeah, we changed the controller. Build. And then go back and refresh. And our message should now say in our view, in the H3 tag, it should now say some content about us. So our code is far, far cleaner this way. We can separate it out. All the logic of what happened lives in the back end of the code. We haven't used the model at all because we're not working with the database, and our views are simply the front end presentation, user input. Much better pattern, much better way to put our applications together. Okay, we'll do one last thing before we get out of here. Any questions so far? Build simply compiles. Rebuild kind of does. Leave that with me so I can give you a better answer. I know the difference, but I want to be able to explain in a way that I don't confuse you. So remind me about that next week. Okay.
So instead of return, if you wanted to redirect,
you would do return redirect to action. Okay. So let's add one more page on here. Okay, so let's write a method on here that returns an action result. What should our new page be? We've got home, we've got about, we've got contact. What do you want to call this page? Well, what's a typical page we might see on a website? About's pretty normal, contact's pretty normal. Give me another normal sounding page. Well, we've got contact already. Gallery, sure, okay. So right now, it throws an error because it's supposed to return an action result and our method doesn't return anything. So let's just return a view. We don't need any other code. We won't worry about the view bag. We just want it to load a page. Let's build. And now we need to create a view with the same name. And we'll just put some static HTML content on it. But we also want it to use our layout file so that we get the same header with the navigation and the footer. So under Views and Home, just right-click your home folder and choose Add. And what we want is this option here that's highlighted in yellow. We want an MVC5 view page with a layout. We're picking with layout because first it's going to ask us for the name of the view, and then it's going to ask us to choose the layout template. We can pick it without a layout, but then our page doesn't get our layout file. So we have no header and no footer unless we manually attach it. Doing it this way, it's a little simpler. So we'll pick MVC view page with layout. We want to call it gallery. The URLs are not case sensitive on Windows, unlike on an Apache server. That's kind of nice. We can browse, it doesn't matter case-wise. So we'll call it gallery. We don't have to give it any extension. Visual Studio will automatically give it .cshtml. Go to Views and Home. So right click and choose Add. MVC5 view page with layout. Call it Gallery. As we said with layout, it now points to the shared folder and says, okay, what's the template? So let's pick our layout file. Right? So it gets the same header and footer as all the other pages. So there's our links to our layout. If we wanted to change it, we could just specify a different layout file here. And then we can just put on a bit of HTML. Because I've already compiled, I should now be able to load this page in the browser by going to localhost/home/gallery. Right. We now have a method in the home controller called gallery, and we have a view inside of views home also called gallery. Give it a shot. So I'll try home, gallery. Again, we have a little lag because I had to compile after we added the new method. Now it loads our page again. Not case sensitive. Disrespect, our URL still runs on Windows. This wouldn't work on Linux or with Apache. So there's our view, and there's our controller method. We just have one more teeny tiny task. And that is, we want to add a link in the header so that we can load the page. Right now, the only way to get there is to actually know this page exists and to type the URL, which isn't good. We're going to create a page. We have to give users ways to get there. So what file do we need to go into? Where would we go to add that link? You got it. So inside of Views and Shared, we want to open up our layout file. We haven't really looked at it. So we can fully customize this. It's got our CSS links here. It has our Bootstrap, our collapsible mobile responsive Bootstrap menu. Our main page content goes right here, gets injected on line 33 with that server-side method, says render body. And then we've got a footer down here, links to jQuery, Bootstrap. So here's our nav bar. We're actually going to change two things. So we've got three links here, home, about, and contact. You notice these links will look unlike links you're used to seeing. Right? Now, we could just write standard HTML links, href equals /home/gallery. That will work. Typically in .NET MVC applications, we actually call the links with server-side code instead using this action link method. We don't have to use it, but it's a bit more explicit that we're not just linking to another page, we're actually calling a particular method in a particular controller. So we're being more explicit about our intent here that we're using an MVC pattern. So I'm going to add another link here. We're going to use the HTML action, we're going to use the HTML library, and it has this action link method, which has 10 overloads. There's lots of different ways we can call this. We're actually going to use this method, the fourth one. You can see the parameter definition, the signature of the method. The first parameter is, what's the text on the link? What should the link say? So in this case, we're going to have our link say gallery. Second parameter is, what is the name of the method we're calling? So what do we need to put here? You got it. We're calling the gallery method we just wrote. And the third parameter, what controller? So it's the gallery method in our home controller. The reason we typically need to specify the controller is because eventually we're going to have lots of controllers. We're going to have like an albums controller, an orders controller, a customers controller. We may have an index method in each one of those. In fact, we will. So it's not enough to just say, call the index method. We need to know index method of which controller. So we don't have to build here. We're just changing HTML. We can just save that change. We should be able to go back to the browser now and just refresh, and we should have a gallery link at the end of our nav bar. So refresh. Here's our link. Now it loads our new page. So creating new pages and links is as simple as that. 3-step process. Write the method in your controller, generate the view, add a link to it so users can get there. Later on, we'll let Visual Studio actually build the controllers and views for us, which is awesome. But first we gotta walk before we can run. Last thing and we'll leave. I know what time it is. Let's just change this. It says application name. Let's change that in our header. So on line 20, we have another action link that says application name, right? This is just a placeholder for us to put in a real name. So let's just call this music store. No compiling necessary. And we're just changing HTML. Go back and refresh. That's got our name here. Okay, I was gonna give you a lab today, but I don't want to keep you any longer, so we will not. Go home. See you next Friday. We'll have a quiz at noon next Friday. Okay. Have a great weekend. See you guys next week. If anybody has any issues getting things set up or configured, I can't stay too long, but I'll take a quick look, and otherwise come see me in office hours on Monday.
Is it possible to double down the cooling system?